Your developer tools should be solving the problems that you hate most. And one of the most annoying experiences I can imagine is fighting your way to get a PR merged when you're trying to ship code fast. I mean, you already had code reviews, design reviews, you fixed all the tests, and fighting to get your PR merged is annoying. You just want to get it merged. If you are working in a large engineering team, you're probably already using a merge queue to help you merge your code, and if not, some jankier version of it, like having a post-commit hook rerun your tests after merges go in, we're requiring that everybody rebase on top of main before merging their code. But scaling on a regular merge queue won't work. You might run into issues like long queue times, which means your engineers might have to wait until the next morning to know whether or not their tests have passed. If you have flaky tests, every single time a test flakes, it needs to be kicked to the back of the queue and retested, and that wastes a ton of CI resource and can choke up your queue really quickly. And if you have a mono repo, you might be wondering why your single line documentation change that only affects markdown documents is queued up in the same queue behind a gigantic backend refactor. In any case, time to merge a PR should be low, and you should never have to fight your merge queue. If you find yourself fighting your merge queue more than the code that you're writing, here are some of the important features that might be missing in your merge queue. Before we dive into any of the fancier features of a merge queue, let's talk about fundamentally what problems a merge queue tries to solve. A merge queue solves the problem where if you work in a large engineering team, people are going to start stepping on each other's toes pretty quickly with different PRs that do different things. And I have an example to illustrate that for you. So I think this is going to be a pretty good illustration of the type of problem that a merge queue aims to address. Let's say we have a pretty simple app here. All it does is it gets a post by a specific ID, and we have some simple tests for this endpoint. Let's say that I am making a change. I'm refactoring the code where I'm going to have posts go under /post/blog instead of /post. Let's say we made this simple change. We're pretty diligent, so we're going to do npm run test. We're going to find that this breaks one of our existing tests because one of our endpoints don't exist anymore, so we're going to fix up that test. Okay, so now we've made our changes, we've fixed our tests. This is going to be the changes that I'm going to be making. So that was the first PR. Let's create another PR and pretend that I'm my teammate. I have a different set of changes in mind that I'm going to add to this repo. I've just checked out main again, and I'm going to add some more tests to our existing suite of tests. Here's our new test. Our new test not only tests that we get a 200 response and the ID returned is correct, we also want to make sure that the body returned is actually from the post that we requested. And let's try that again. Let's run the tests. Okay, so now we've created two PRs. Both of them are going to be passing tests on main, but something happens when you merge both of them. So we've just created two pull requests, and both of them will have test pass against a snapshot of main. But because we don't have a merge queue, both of these changes, when they're put together, will actually break main. Here's what's going to happen. So we have our /post/blog here with the ID, and on our first test, we have the refactored changes that we have with getting started. But you'll realize that because the second PR that my teammate created didn't have the refactor changes that I created, this is now going to break all of the tests on main. And indeed, if we run our tests now, we'll realize that we've just broken main because we've refactored only one of the tests, but not the new test that my teammate has created. So we've now successfully broken main. No one likes breaking main, especially not for such a preventable and silly reason. This is where merge queues come in. Merge queues let you do something called predictive testing that can help with this problem. Your merge queue will line up your PRs in an orderly fashion and decide which PRs will be merged first and which PRs will be merged after. Each PR that is going to be tested will always be tested, including the changes of PRs that are going to be merged in front of it. You'll always be testing against what main will look like, including all of the changes in front of you, which means you're testing predictively. While doing this might sound super slow, a good merge queue like trunk would also allow you to test concurrently. This means allowing you to test multiple different PRs at once that enters the queue. This would drastically speed up your merge queue. This also opens up an interesting opportunity for optimization called optimistic merging. Optimistic merging is really simple. If your PR passes and tests are run predictively such that your changes include all of the changes ahead of your PR, you now know that every PR that your PR depends on must also pass the test, which means the PRs in front of you are safe to merge. If these ideas sound really simple to you and they sound like common sense, great, that's the way it should be. Tooling should be very, very simple and intuitive to understand so you never have to fight it to do what you expect it to do. The common sense principles of optimistic merging also unlocks another powerful feature that Trunk's merge queues include to help you combat flaky tests. In predictive testing, we're relying on the information that your PR must also include changes of all PRs in front of it, and so if your tests pass, PRs in front of you should also pass. If you find that one of the tests didn't pass, it's probably flaky, and since your PR includes those same tests, you can still safely merge into main. Now, in a perfect world, we would have stopped to fix the flaky test, but we have deadlines to meet and we have places to be. So it is much more important that we don't let a flaky test stop you from shipping the code that you need to ship. It would be silly. Tests should prevent pain, not cause pain. Okay, another way to optimize your merge queues is with batching. Here's how it works. If we don't have batching, we would be testing each of the PRs one by one. We'd have a really deep queue. It's expensive in terms of CI resource and painfully slow. With batching, we'd be testing PRs A, B, and C together in a big patch, with all of their changes merged together. If we know that those changes together will pass tests, that's good enough. We don't care if they will pass tests separately. Assuming your engineers test before submitting PRs, for the most part, batching has a great potential to save you lots of time because, for the most part, most of the tests that are run in your CI pass anyway. In the odd chance that something does get caught or a bad PR gets submitted, it will be booted to a separate queue where it will be bisected, retested to find the bad PR. Now, if a PR passes, it'll be entered to the back of the original merge queue to be merged, and the problematic PR will be picked out and it will be kicked out of the queue. Another problem that I've run into personally in the past as a technical writer is I've submitted documentation PRs and wondered why they're stuck in the same queue with these gigantic backend changes, right? Your merge queue should understand common sense. It should understand that my documentation change that changes a markdown file should not be in the same queue as backend changes. Your merge queue should be able to analyze exactly what changed in each PR. That means your backend changes shouldn't block any front-end changes. Any front-end changes shouldn't be blocking your documentation changes, even in a giant monorepo. So Trunk leverages tools like NX and Bazel to understand which tests need to be run and what changed in your repo. As a fun aside, all of these powerful features found in Trunk Merge can also help you build fast and scalable monorepos that can handle thousands of developers PRing into that repo at once. This is not something that your average run-of-the-mill merge queue can do. If you're currently battling a really bad merge queue, try our merge queue. And if you're just merge queue curious, you can always still check out our merge queue and see how really big companies scale their merge process. If you want to talk to us about Trunk Merge, head to trunk.io/merge and book demo, or check out our docs to try it yourself.